This presentation speaks to an uninterrupted power supply, commonly known as UPS. There is often a UPS located between the generator and the emergency power system. The UPS or battery backup is equipment that provides instant energy power when utility power fails. The on-battery runtime of most uninterruptible power sources is relatively short, 5 to 15 minutes, being typical for smaller units, allowing time to bring on an auxiliary power source online or to properly shut down the protected equipment. The UPS is mostly used to protect computers, data centers, and communication equipment for obvious reasons. The UPS equipment comes in all different sizes, depending on the equipment to be protected. UPS functions. The uninterrupted power supplies can also correct common utility power problems such as power failure, defined as a total loss of input voltage; surge, defined as a momentary or sustained increase in the main voltage; sag, defined as a momentary or sustained reduction in input voltage; spikes, defined as a brief high voltage excursion; noise, defined as a high frequency transienter, an oscillation usually injected to the line by nearby equipment; frequency instability, defined as temporary changes in the mains frequency; harmonic distortion, defined as a departure from the ideal sinusoidal waveform expected on the line. The UPS is categorized depending on which of the above problems are addressed. The categories are online, line interactive, or standby. Generator concerns that a UPS system can resolve. Frequency variations. The voltage and frequency of the power produced by a generator depends on the engine speed. The speed is controlled by a system called a governor. Some governors are mechanical, some are electronic. The job of the governor is to keep the voltage and frequency constant while the load on the generator changes. This may pose a problem where, for example, the startup surge of an elevator can cause short blips in the frequency of the generator or the output voltage, thus affecting all other devices powered by the generator. Power factor. A problem in the combination of a double conversion, uninterrupted power supply, and a generator is the voltage distortion created by the UPS. The input of a double conversion UPS is essentially a big rectifier. The current drawn by the UPS is non-sinusoidal. This causes the voltage from the generator also to become non-sinusoidal. The voltage distortion can then cause problems in all electrical equipment connected to the generator, including the UPS itself. This level of noise is measured as a percentage of total harmonic distortion of the current. Classic UPS rectifiers have a THD level of around 25 to 30%. To prevent voltage distortion, this requires generators more than twice as big as the UPS. There are several solutions to reduce the THD in a double conversion UPS. Passive factor correction. Classic solutions such as passive filters reduce THD 5 to 10% at full load. They are reliable, but big and only work at full load, and present their own problems when used in tandem with generators. An alternative solution is an active filter. Through the use of such a device, THD, it can drop to 5% over the full power range. The newest technology in double conversion UPS units is a rectifier that doesn't use classic rectifier components, thyristors and diodes, but high frequency components known as IGBTs. A double conversion UPS with an IGBT rectifier can have a THD as small as 2%. This completely eliminates the need to oversize the generator and transformers without additional filters, investment, cost, losses, or space. I hope that helped. Thank you for listening. Bye now.